pretty good Christmas break. It was extended, which was kind of nice for you. I'm going to go over the schedule and whatnot first. I know I did post it, but I just want to talk about a couple of things. So we left off with chapter 5. We started off with mean, median, mode, and range. Then we looked at some histograms, and from the histograms, we created frequency polygons. Then we looked at grouped data, and then calculating mean, median, and mode from a frequency table, and standard deviation. So the first thing I want to mention is we're not going to be doing anything that requires the calculator this week because you don't have a calculator at your disposal. So these things that I just mentioned here on the first slide, can someone tell me if you can see this slide okay?
Yeah, we can.
Perfect.
Yeah.
So until now, there are things that you did learn about the calculator already. You are responsible for those, but this week I will not be including anything that require a graphing calculator. Will you need a scientific calculator? Yes, you will, to do just some small calculations. So if you can get one of those for class, or if you have it on your computer, I know a lot of them you can just access a calculator at your, at your laptop or at your desktop, whatever you're using. Okay, so I did put the schedule up for this week. So today we are going to, I'll take any questions you have on chapter 5 up till now. And then we're going to look at something called normal distribution. Okay, and we're going to be actually spending this week on normal distributions with some added topics that go with normal distribution. Okay, so I did post this, so hopefully you saw it. Tomorrow you're going to get a skill check that'll be due before midnight tomorrow night. And you'll have another one on Thursday and another one on Friday. So those will be quick things that you'll do online. Okay, and I'll talk more about those tomorrow when we're done the lesson. So as you can see, there's no test or assignment. They're going to be quick little check-ins that you will do for this week. So you need to be here and you need to be paying attention and you need to be completing the practice I'll assign you to do. So we are required to do 40 to 50% of the time for class synchronous, which means I'm available to you, talking to you, teaching a lesson. The second part of the lesson, the second part of the class, students can work on questions. You can ask questions then to get some help with anything that you need to get help with. Okay, so you still need to be in class for the 75 minutes. Next week, this is the plan for next week in person, because I have no information to think that we're not going to be here in person. If I get information, you will be the first to know. And if you have information, you can certainly tell me, because that's always helpful. So Monday, we'll do a review, so a week from today. So essentially, we're finished the course on Friday. We've had to cut out a few things, obviously, because we're pressed for time. So we'll review chapter 5 on Monday, and then we'll have an assessment on Tuesday. If we're online, all notes are permitted. If we're in person, one sheet of your own handwritten notes, double-sided, is permitted. If we are in person, you do not get to use all your notes. So just to make that crystal clear, you will be allowed to have one sheet of notes. Okay, so we'll talk more about that if we need to later this week, if there's any new developments, if there are any new developments, I should say. So next week, on Wednesday, Thursday, and Friday, we will be doing exam review. Okay, so the last new thing we'll do will be on Friday of this week. So hopefully you all had a chance to have a look at that in classroom. Right now, are there any questions that you would like to go over from chapter 5?
Wait, so are we still supposed to have an exam?
Oh, good question. So as of right now, exams are the week of January 24th. And as of right now, you will have an exam during that time in person is what we know at this time. If we are not in person, then I don't think we're doing an exam online. We would just go with the 80% of the course material that you have completed. So if we are in person next week and in person the following week, you have an exam the following week of January 24th. If we are not in person, it's my understanding that we're not having an exam. Okay? Any other questions? So you've had lots of time to complete all these things that I've already mentioned. So all this, the worksheets are posted, all the solutions are posted, work solutions actually. So if you're not caught up on this, you need to be, because we need to be thinking final assessment for this course, and at the very least, a final assessment for this chapter. And I want everyone to do well on that. Okay, so today I'm going to go over a few things. I have a tablet here, so I will be drawing on the slides that I've created. I will post things right after we're done, so you can have a look as you start to work on the questions that I'm going to assign. So, a normal distribution. Sometimes when we have data, a lot of data, it has a special shape. And data that when graphed as a histogram or frequency polygon can be said to be normally distributed. And when it's normally distributed, it has some really cool properties. So if you look at this graph right here, I don't know who this is. Okay. Sorry. So we're starting at a low point and then we're reaching a high point here. So it kind of looks a bit like a parabola, but it's not. It's what we call a bell-shaped curve. Okay? It's symmetrical about the middle. So the middle of that graph, I'm just going to make this a little bigger, would be right here. So whatever is happening on the left is happening on the right, so to speak. So it has an increase to a maximum point, and then it's decreasing again back down to the x-axis. So we would say that this is normally distributed about the mean. So if we have a mean, the mean would be right here, population mean. It's called unimodal symmetrical distribution. There's only one bump in the curve. That's why it's called unimodal. Okay. So the properties that we have, it's symmetrical. So as I just mentioned, it's symmetrical about the mean. So it's about the center, which is where your mean is right here. The interesting characteristics here are the mean, the median, and the mode are all the same, or they're pretty close to being the same. So let's say the mean is 70.3. The median and the mode could conceivably be those exact values or pretty close. So maybe 70.5 or 70, something like that, but they're pretty close and they follow the line of symmetry. So right here in the center. So it's said to be shaped like a bell, peaking in the middle, and then sloping down toward each side. So it's kind of like, you could even think of it as kind of a mustache, flaring off here to the left and to the right. But remember, down here, this doesn't go back up. This actually just kind of kisses the x-axis here. Okay? Approaching zero at the extreme. So it might look like it's touching the x-axis, but it really isn't. It's just kind of approaching it. So these percentages are really important for you to know. If you look here at the bottom of your graph, this is actually plus 1 standard deviation, although it doesn't say 1 in front of it, but this is plus 2 standard deviations, and this is plus 3 standard deviations. So the mean plus 2 standard deviations is what this would translate to be. So remember that symbol, we learned that way back, so you might want to go back and review your symbols. That's what it means. Okay, So this is going to be the mean minus 1 standard deviation. So if you think of this at 0, so this is actually mu plus 0 standard deviations because it's at the center of your graph. So 68% is within 1 standard deviation. So for example, this would be 68% in here. Right here. 95% is within 2 standard deviations. So for that one, we would go 2 this way to this guy, and this would be 2 this way out to here, which would mean 95%. So if you had 100 pieces of data, 68 of them would be in the red area, 95 of them would be in this area right here, in this orange area. Okay, I don't know if somebody wants to get in or what. Just a second. Don't know who that is. Okay, so 99.7% is going to be all of this and all this in here. Okay? Okay, so as we go out on the graph, what you're seeing is you're reaching more and more values that are part of this particular population we're talking about. So a nicer diagram is this one. So you might want to take a moment and just sketch a quick little curve in your notes, and you can put this in here. So 68% is in yellow, and then in red would be 95%. But remember, 95% is all of this. And then 99.7% would be the blue. So what percentage am I missing from the total? What's perfect percentage? It would be 100%. So I have 99.7 accounted for. So minus 99.7%, that gives me what? 0.3%. I'm just going to see if that's somebody who needs to be let in. Sorry. Oh, they're gone. Okay. So I have 3% that I have to share here and here. So this is going to be 0.3%, but I have to share it divided by 2, which is 0.15% right here. I'm not even going to try to write that in there because I know I probably can't do it. So now this would represent all the data that you have. So you might say, well, why do we need these? Well, sometimes we're only talking about within 1 standard deviation or within 3 standard deviations. We don't want all of the data, depending on the question we're being asked. So this is actually in your textbook also in chapter 5. So if you have your textbook there, you can have a quick look, or you can wait until the end when I post this. It's up to you. Any questions on the curve? The mean is always in the center, always. So the mean would be here. So whatever's going on the right is going on the left, so to speak. Okay, so how will we use this? What do we need it for? Okay, so for example, suppose 960 students took a test, and the following is true. The results were normally distributed. So as soon as I see the results are normally distributed, this is what I can draw. I can draw a nice little bell-shaped curve. That's what I'm allowed to do. So when you see this, you're allowed to do this. Okay? The mean is mu is 73. So I know the mean always goes in the middle of a normally distributed set of data that's graphed. So my mean is going to go right here. And I know the mean is 73. The standard deviation, which is sigma, it's just a circle with a little hat on it, was 7. So if I look back at my graph here, if I add a standard deviation to the mean, it's the mean plus a standard deviation. So this one, I'm going to add a standard deviation. So this is now going to be 73 plus 7, which is 80. Then if I add another standard deviation, I'll be at 87. And then another one, I will be at 94. We only graph 3 standard deviations. So this is plus 1 standard deviation, plus 2, and this is plus 3. So then I have to go on the other side. Oh, that's really awful, sorry. It looks like it's a lot easier, I'm sure, to do than it is. That's fine. So 73, now I have to minus. So 73, this is what I was saying about a little calculator if you have that. 73 minus 7 would be 66, I think. And then if I subtract another 7, I'm down to 59, and then this would be 52. Whoops, not there. This last one would be 52. So on this side, though, it's minus a standard deviation. It's minus 2 of those, which is basically minus 14. And this is minus 3 standard deviations. Okay, so I'm asked to draw and label the curve. So this is 68% that I have to share. So I get 34 and 34. The next one is 95%. Well, 95%, but minus the 68 I already have accounted for, is equal to, I think, 27%, if I have that right. So this is 27% and 13.5 and 13.5, because I have to share that. So everything is symmetrical. So it's 13.5 over here. It's 13.5 over here. And then the next one I've already now accounted for 95, so 99.7% minus 95% is equal to 2.7%. But I have to share that. No, sorry, it's 4.7. Can't add and subtract in my head today, apparently. 4.7. So if I divide that by 2, because I have to share it, I get 2.35%. So 2.35, see if I can squeeze it in there. 2.35%. So there's my curve. So there's a couple of questions here. It says, within what range of scores would 68% of the data fall? Well, 68% is plus or minus 1 standard deviation. So I'd actually be looking at this region right here. So it says, what range of scores? So between 66% and 80%. Whoops. And you should always include your units because these are real life applications. Okay, between what percentage it says of students scored between 59 and 87. So I'm going to go up to my graph here and I'm going to source out where do I see 59 and 87? Well, 59 is here and 87 is here. So the total percentage here would be the 34 and 34 and 13 and a half, 13 and a half. So that's 2 standard deviations. So it should be 95%. And the last one says, what is the median and the mode? Well, it's normally distributed. So I can say a normal distribution, I'm told in the question. So therefore, I can say the median should be equal to whatever the mean is, which is 73. And the mode should be also 73 or approximately 73% because they're scores, so they're in percentages. Any questions on that? So every time you get a scenario, you might want to sketch a quick curve. It didn't take me long to do. I think you saw. I'm not being all fussy. I'm just making a bell curve and just labeling those percentages that are right here. Okay? Okay. So I just want to put this one here. Okay, generally measurements of living things is what we're going to be talking about in some cases, such as mass of whales, the height of trees, the length of a dolphin, I don't know, have a normal distribution. If you're given a set of data and you want to determine if it is normally distributed, you have 2 choices. You could graph the data to see if it looks normally distributed. So if it's normally distributed, it would look like a nice bell-shaped curve once you plotted it. So if you think of your histograms that you've done, if they had like a nice cascade up to a max and then fell down to the x-axis again, that would be a good way. Or you can find the standard deviation and determine if approximately 68% of the data is within 1 standard deviation, 95% within 2, and 99.7% within 3. So, as I said before, if we had n, which is the number of pieces of data, to be 100, within 1 standard deviation, that would be 95 of those 100, 99.7, so we could say 99 or 98. And here we would say 68 of those pieces of 100 data. So normal curves can vary in 2 ways. The mean determines the location of the center of the curve on the horizontal axis. So if we look below here, if this is a normal curve, which it looks like it's supposed to be, I think I could estimate the mean here to be about 9, thereabouts. The mean for this guy looks like it might be more like 33-ish. Sorry, that's really crooked. So this mean is 9, this mean is 35. So that's the first one, here's the second one. So the standard deviation is the spread of the data. So this graph looks to have more spread. So remember, we did standard deviation before the break. Larger standard deviation means more spread. So it means the value for the standard deviation would be bigger. This one has less spread because the data is tighter together in the graph. Okay, so we did talk about standard deviation before. So if you might have to go back and do a little review on that to make sure it's fresh in your mind. Okay. So, see if I can make this so that it's a little bit smaller so you can see it. Or no, I think you can probably see it okay. So for this question right here, or this particular section, I should say, I would like for you to try these few questions. I'll give you a couple minutes. You don't have to draw them. You can just literally put down E, F, G, H, I, and J. I'll give you about 5 minutes just to go through. I'll do the first one with you so you know what we're doing. So if it says what percentage got between 66 and 73, I'm looking at this region right here. So in each case, what you might want to do is think about where the mean would be. So I think the mean we're given is 73. And I believe these were all the values that we came up. So this hinges on this question, this example that we just did right here. Okay, so I sketched the curve. It's all the same values, 52, 59, 66, and so forth. They're all right here. So now we're just going to work on a couple of questions. So if you want to just put down E, F, G, H, I, and J, and just try those. So between 66 and 73, can someone tell me what percentage they think that is? For that guy?
Is it 34? 34%?
Anyone?
Is it 34%?
34%, excellent. So I know this is within one standard deviation total, but I'm only looking between 66 and 73. Okay, so I'll give you a chance to try those. I'll leave them up on the screen so you can see them. Oh, just let me go back here, sorry. I'll just leave those up for a moment so you can do those. Is Evan here? Did Evan arrive? No. Nicholas Corey? Zoe?
I'm here.
Who's I'm here? Peter? Or Nicholas Corey, sorry?
I mean, I did go outside sometimes. I had work, but that's it. No, I mean, we're going to be off school until spring break.
Nicholas, was that you who said you were here?
Yeah, I'm on. Can you hear me?
Okay, thank you. Zoe. Is Zoe here?
Yes, it is.
Yeah, I'm here. Yeah, I'm here.
Yes?
Yeah, I'm here.
Okay. You might want to turn your volume up a little bit because I couldn't hear you there when you had your mic on. Mo, what about you? Did you arrive? Michaela.
I'm here, miss.
Okay, you're here. Thank you. So write down what you think. Did anyone get an answer for F? Between 59 and 73. So that's one standard deviation to the left. So that would be 34%. Plus, we have to go another standard deviation to the left, which I think is 13.5. Is that right? So what does that
Yep.
equal? Is that 47.5%? The other way you could do this one is you could say it's 2 standard deviations, but just minus 2. So for 2 standard deviations, the total is 95%. So essentially, isn't it just half of the total 95%? So someone else could say, well, I just want to do what I know. 95% divided by 2 is 47.5%. Either or works just fine. So what percentage are between 57 and 59? 52 and 59, sorry. That would be right here. So if I go back to my curve right here, isn't that 2.35%? So 2.35% works just fine. It's a small little area, so the percentage should be really little. 2.35 would be in here. Less than 59. This is a tricky one. Maybe, maybe not. So less than 59 means everything to the left of 59. So this first little group here, I think, is 2.35%. But there's something you have to add to that. It's really thick. If it's less than, I have to get the little piece on the end too. Does anyone remember what that little piece on the end was?
Wasn't like 0.3?
0.15, I think, isn't it? 0.15%. So it's not really another bar. I probably shouldn't put that in there. I'm not going to put that on. I'm just going to do it like this. So if you have your graph there, you can do 0.15%. So I'm looking at between less than 59 here. So that's going to be the 2.35 and the 0.15. So there is a difference between just saying between 52 and 59 or less than 59. So we would have 2.35% plus 0.15%. And if I add those up, I think I get 2.5%. Emmanuel, was that you who volunteered here for this one?
Yeah.
Are you good with that one?
Yeah.
Okay, so we have to make sure we get that little piece on the end. So we might want to just put a little star there by this guy. So here's another one where it says less than. So less than 66. So that means everything here, and also we have to go less than. So it's right over. It's everything there. So essentially, there's a couple ways you could do this. You could say, I'm going to take the total, and I'm going to subtract all of this and all of this. Well, I think that this is 34%. Oh, that's messy. This one little guy right here is 34%. How much is this to the right of the pink line? What percentage is this total from the pink line to the end?
It's 50%.
50%, good. So if I take out this 34 and I take out the 50, what do I end up with? Is that 16? I think that's 16. What if somebody didn't like that though? What if they said, well, no, I want to do it the other way? Could I also say 0.15%, which is the far left, plus 2.35%, which is the next block here. And then I think this guy is 13.5%. Is that another way we could do that? Either way we slice it, we're going to get 16%. But this question actually says something else. It says, how many students? Well, how many students do we have total? Well, I think it says I have 960 students took a test. So 960, and I need to know 16% of those. So 16%, what is that as a decimal? 0.16. So I would get 153.6 students. Can I have part of a student? I don't think so. So how many students would I report here? Well, I would prefer if you would record 153 students because I can't automatically round up. I would round down here because I only have 0.6. I know you might say, well, Miss, that's more than half. Yes, it is, but it's of a unit. So I would round down to the actual number of units we have, whole units. Okay, this one says greater than 73, and I want how many students? Okay. Well, what percentage is greater than 73 here? What is this? What are all these percentages added up to the right?
50.
Isn't it 50%? This is a symmetrical curve. So half of the values are on this side and the other half are on this side, approximately. So if I'm looking at greater than 73, I'm all in on the other side. Whoops. So I would have all this region right here. All of it, including what's beyond here, that little piece on the end. So it's 50%. If you're not sure how we get that, this first one's 34. The next one is 13.5. The next one is 2.35. And the last one is 0.15%. If you add all those up, you're going to get 50%. By looking at it, this is 50% above, this is the other half below. So how many of the 960 students? 960 times 0.50, I think, is 480 students. Okay, so it might be something completely new to you. If you've done some science classes, maybe you've run into this before, I don't know. It doesn't matter. We're taking it from the top anyway, like you haven't seen it before. So I have a worksheet for you to work on for Tuesday. And in these slides, I've also included the solutions starting on page 12. Okay? And if there's any there, the class is still on now, so it would be great if you actually worked on these now, so then if you had some questions, you could ask me. Okay, so I'm going to post these in Classroom for you right now. I'll just save it as a PDF first.
Miss Bacich?
So if I go here. Would anybody like the worksheet posted separately, or is it okay to have it just embedded in the notes? What would you, so that you only have one place to go? I thought it might be easier to put it here.
Yeah, I think that's easier.
Is that
Yeah, that's
okay?
fine.
Because then here are the questions, and then here are the solutions. It's all together. You don't have to flick to different ones. Is that sufficient? Or I just want to be able to be helpful, because I know this online thing's a bit, depending on your level of comfort. Perfect, okay. All right. So I'll leave the questions up for right now so you can see them. If anyone would like me to go back to any of the slides, just say the word so I know that you need something explained. I'm happy to go back if you need me to.
So, are we allowed to leave now, or?
I would say maybe at 10:02 at the earliest you should go, because I would like you to try a few questions while you're here and see if you're doing okay.
All right.
Okay, so I have 142. right now. So if you want to work somewhere else on these, you can, but I'd like you to hang around till about 10 to 2, just to make sure that you have if you have questions, you have a chance to ask them, that's all.
Sorry, could you repeat that? My phone kind of cut out.
Oh, I just said I have 1:42 right now, 1:42 p.m. So if you can stay till about 10 to 2, and that way, if you're working on some questions, you can ask me for help if you need it. That would be great.
All right, thank you.
Okay, you're welcome. Can someone just let me know if you got a notification, please, so I know it worked?
Miss,
Yes.
I missed the first bit of class. Could you go back to the first slides and explain them?
Do you have a specific question? Like, I don't have time to reteach the whole lesson, right? Like, how many slides did you miss? Can you have a look at them first, Michaela? Just have a read through and see if you're okay, like see what you need to ask me?
Did you post the slides that we just did?
I posted everything. Did you not get a notification?
No, but I'll look on my Google Classroom right now.
Yeah, just check and see if you have it. And I mean, we're here until 2:08, so you have lots of time just to have a read over. And if there's a specific one you want me to go back to, I'm happy to do that. Zoe, are you here?
Yes, I am.
Oh. Mohammed, is Mohammed here? Oh, Mohammed, you are here. Okay. I can't hear you, though, with your mic.
Did it say I wasn't here?
You might need to turn your mic up. Oh, it's not working. Okay. What about Evan? Is Evan here?